Hey everybody, this is our piston retraction mechanism improvement project. My name is Tanner.
My name's Evan.
And I'm Oak.
So a little information about our sponsor. It's called Spear Brake Defense. They have a patented spear brake technology that's sponsored by the U.S. Marine Corps. Its application is for military amphibious vehicles. They're located in Erie, Pennsylvania, and our contact with the company is Joe Fiore, and he's the Director of Research and Development there.
A little bit of background about spherical brakes. They are a compact, high-performance braking system developed by Spear Brake. They use spherical pads and they use 2 calipers per wheel. They're designed to be lightweight, modular, and space-efficient applications. They're commonly used in military and advanced vehicle applications. Unlike traditional discs, these systems apply uniform pressure around a spherical rotor. They have 2 calipers clamped from opposite sides to engage the rotor evenly. Here's a need and problem statement that we just followed to actually make sure the project was done correctly. The need statement is the pre-existing brake retraction mechanism lacks an efficient attachment method and has a high potential for leakage. The problem statement is we need to develop a retraction mechanism that can be attached efficiently while also minimizing the chance of leakage.
So criteria are things that need to be maximized or minimized. We have maximize the piston retraction performance. That's going to involve making sure that the piston doesn't get stuck at any point during its up and down motion. We need to maximize manufacturability and minimize assembly complexity. These two go hand in hand because we don't want anything so complex that it can't be manufactured easily, and we don't want too many parts because that introduces more places for things to fail. We also need to maximize safety since this is a brake system, so we need to eliminate any likelihood of leakage or corrosion or any place that this could fail. Constraints are must-haves given to us by the sponsor. So one is that the retraction design needs to be compatible with the existing caliper design or with just a couple of minor modifications. Another is that we all need to comply with a non-disclosure agreement that we all signed. Lastly, the design needs to be dyno tested in Detroit, Michigan for performance and reliability. Dyno testing involves setting the brake system up on a test stand and seeing how it performs under heavy load.
So this is our current design as it is now. On the left-hand side, you can see it has holes in the bottom of it. This is to allow brake fluid to enter and exit the piston freely. This is done to prevent the chance of brake lock and makes it more retractable as well. And on the right-hand side, you can see when it's fixed in the caliper that it doesn't go all the way through the bottom of it, and that is to make sure that there's no chance that leakage could occur there. And on this next slide, you can see that it is broken up into 4 simple components. That's to maximize its manufacturability as well as its assembly. It's just the entire thing is assembled through 2 3/4 inch threading and put together.
Now we're going to go through the implementation and testing of this process. These are some of the rapid prototyped parts that we were able to put together for the design. This right here would be the piston itself. This is the piston cap. This is the center support. And this would be just a rapid prototype of the spring. So the center support will go inside of the piston. The spring will go inside of that as well. And then the piston cap will thread onto the actual piston itself. And then once the whole thing is assembled, the whole entire assembly goes into the caliper, and then the whole thing will screw in. And once it's fully in, it'll be torqued down. This is a cross section of how the whole assembly works. This here is the fully machined caliper with only one of the pistons installed. We were only able to manufacture one of them in steel. When brake fluid enters the cavity, the piston will extend and retract just as we had expected. This here is the brake pad. It's shaped like that, so it'll fit over the spherical rotor, just like this, as you can see. The brake pad, along with the spacer, will be installed in the back of the caliper, just like this. And the spherical rotor will be on it just like that. And whenever the piston breaks, it'll extend and stop the vehicle.